Hi LCMSD families. Today was our third installment of our CGI coffee chats for the school year. The focus of this coffee chat was on the strategies that you may see your child using at home and then how to support those. So we're going to expose you to a number of different strategies that really build into student flexibility. So I'm going to turn it over to Beth Hawkins, our math coach and intervention teacher.
After we gave parents a chance to have a little practice with some problem solving themselves, we went over some strategies that parents might see their students use when they're working on math in the classroom. So first we talked about some addition strategies, and we worked on showing where we start with the more manipulative use and using one-to-one correspondence, and then working our way into getting more towards that algorithm, which is the way that most of us learned how to do these kinds of problems when we were in school. So some of the ones we talked about with addition, the number line is a really powerful strategy. And that's where if I'm doing 14 plus 18, I can start at 14 and break it up into pieces, the 18 into pieces, and see where I land. Often kids will choose to add, say, 6 to the 14 to land at a benchmark number, and then they'll add 10 and then 2 more. And so that way they're adding 18 in a way that feels really comfortable to them, and they're flexible with numbers. Or they can use the commutative property and flip the order. A lot of students will like to start with the bigger number, so they'll start at 18, and they might add 10 because that feels comfortable, and then 2 to get to a friendly number, and 2 more, breaking that 14 into pieces, and still landing at 32. Looking at subtraction strategies, again, you'll see the number line is here. What's neat about the number line with subtraction is kids can either start at 51 and work back, counting 37 back to see where they land, again, using benchmark numbers that are comfortable to use, or they can use that inverse, and kids can use addition to solve a subtraction problem. So they're finding the difference between 37 and 51, starting at 37 and working their way up and seeing what that space in between 37 and 51 is. So that really builds into the flexibility of numbers and students understanding the connection between inverse operations. We also looked at the strategies of compensation, where with 51 minus 37, I could take away 1 from each of those and still find the space in between. I would still end up with 14. Or I could even take away 2, and now my problem is 49 minus 35, and this way students don't have to do that borrowing that can be so confusing to them. We also looked at using place value and then moving into the algorithm that we all learned. With multiplication, there is a lot of different strategies here that students use, again, starting with the more concrete. So if they're doing 32 times 12, they can break 32 up into 30 and 2 and make 12 of those, and it's much easier to find 12 30s and 12 2s and then add those 2 pieces up. We also talked about doubling, using an input where you use the numbers that you know to find the answer. So if a student knows that 10 times 32 is 320, and that 2 times 32 is 64, that's the same as finding 12 groups of 32, and they can just add these 2 numbers up to get to 384. And then that connects over to this box method. We're breaking apart numbers 30 plus 2 and 10 plus 2, and you find the product of each of the pieces, 30 times 10, 2 times 10, 30 times 2, and 2 times 2. And eventually, when students get really comfortable with these different strategies, they'll learn how to do that algorithm, but it will make sense to them what they're actually doing with the numbers. Looking at division, again, a lot of different strategies. What's powerful for students with dividing is learning that they can, again, use that inverse operation just like with subtraction. So they can use multiplication to find the answer. They can look to see how many 15s go into 375. So if they know 20 times 15 is 300, and they know 5 times 15 is 75, they can pull that together and see that 25 15s makes 375. So by using pieces they know, like their 10s, their 20s, 1, 2, 3, 4, 5 groups of, they can find an answer that makes sense to them. We also talked about this partial quotient strategy, where students, again, are thinking about the numbers that they know. So if they know groups of 10, they can use that. So 15 goes into 375. If I don't want to do the long division way, I can think that it goes in 10 times, take away 150, I'm left with 225. I can again go in 10 more times, take away another 150, and then I get that last group of 5 15s till I get to 0. And then I find that 25 15s makes 375. That's a favorite that students really love. And again, with the goal of getting into long division. But once they get here and they've tried these other strategies, they understand more what it is they're doing when they do that long division strategy. The last one we looked at was comparing fractions, so really building students' fraction sense. Most adults learned as kids to compare fractions by finding a common denominator. That's here, and then looking at the numerator, and that's what you compare. That's a goal at the end because it is pretty efficient, but we want students to work up to it. So they can draw a model, they can do a number line. They can also look at things like using a half as a landmark. So if 4/9 is less than a half, 3/5 is more than a half, then I know that 3/5 is more than 4/9 without ever having to find a common denominator. Also, I can think about a common numerator. It's common to think of a common denominator, but a common numerator is really helpful too, because if I know that fifths are larger than sevenths, then I knew 2/5 will be larger than 2/7. And again, this idea of when we're one away from a whole, if I know with 3/4 and 2/3, I know I'm one away from a whole here. Well, I know a fourth is smaller than a third, so I know it's missing a smaller piece, so 3/4 is my larger fraction. So again, different ways to think about fractions that build up into the strategies that we all learned that are most efficient. So in the PDF that is sent out with this link with this video, there will be these resources will be up there, so you can look at these to help you help your children at home when they solve math problems.